Alright. I don't know what's going on here. Seems to work now. Okay, I'm just gonna continue. So let's see. Let's iterator. So next, this would be, yeah. So first we get the info, and then if info state is shown, then we return. What would the key be? So the key, so yeah, the key would be keys index. We would need self here as well. Alright, and then we also want to check if index is more than or equal to keys length, then we return no. Alright, so I think what we'll do is if it's shown, we're just going to return the info. No, it's not. Alright, we need states as well, I think. Yes. Okay. So we'll return if it's shown. If it's not shown, we'll return next again. So this basically acts as a filter and mapper in itself. So we're doing everything in here, and then let's also provide a reset. Which just sets index to 0. Do we get like capture here? Can we just do self? Would that work? Keys. And now I guess we can do this to get the actual iterator out. Okay, and then let's get rid of this crap. And now that would be the iterator, and none of these is really, well, everything is copyable basically. So this would work. And what I was thinking is, if this works, then what we could just do, we could still return a generic iterator, you know, in this sort of type, because we could just fill this in here to return a generic iterator, and then you can still, you know, the good thing about that is then you have a way of like using, for example, map iterator over it and stuff like that. Then you get a nice type that you can actually see, oh, it's an iterator over whatever we have here. So so yeah, this would be like data. Oh yeah, actually let's look at the slice iterator. So the way this works is, since you have to pass in self here, or self is actually data, which is iterator data, which is just an array here of bytes that we have to cast into ourselves in order to get self out. So that's like one more step that you actually have to do in order to make this into a generic iterator. So I don't know, maybe we just return, well, I guess we could return we could make a type here. We could make well, actually this would be like, let's do shown info iterator, and then we can just take everything in here. And we can do Now I have to say this, so shown info iterator. Alright. Yeah, now I don't need allocator at all there. Okay. So actually, I really like this, like iterators. It's just the fact that you don't need to allocate. Right. And here's like get shown options iterator target. So we basically do the same thing, except now we pass in options there. We don't need to pass in allocator. We call this function instead, and now we get this type here. Which, where should we put this? Maybe up here. Down here. So dialogues. Yeah, I guess we have to because now we have to change this type here. I don't know. It would be cool if we could just say iterator dialog option info. I mean, it's very clear what we're doing here, and then we have a common interface. But I guess that's not really how we're doing things. So, but yeah. Iterator, yes, iterator. So we can just return that, that's fine. And then wherever we're using this, which is over here, very good, we can do iterator instead. So now we get this iterator here, and we don't need to free it. Perfect. We don't need to allocate a new response. We can just we can create our own iterator now, so we can just say return so let's make a new iterator which will map that iterator. I guess what you could do no, never mind. It's just too cumbersome to work with the higher order iterators because you need a pointer to the previous iterator, and then you can't return it. So that's the whole issue here. This would be this. We're gonna return now a option response instead. And so, yeah, still need like, well, actually, you know what? We don't even need index now. We can just say next is shown. Let's do shown options is shown info iterator. Don't get it, we can return null, and then basically do what we do here. So we want to return this. Okay, and then we need a reset function, which we just call reset on. So it's very easy actually to write a higher order sort of iterator with this style here. Okay, and then we don't need to allocate, we don't need to loop through, we can just return that with... I wonder if you can do this, if you can set that there somehow. Does it know how to capture it? No, it's not, it doesn't work. There we go. I guess because you could technically move that type, like have the type be somewhere else, and then it doesn't make sense. Alright, let's call that info, I guess. Alright, expected. Oh yeah, so now we can... Oh yeah, so we have to like turn this into an iterator now instead. So let's take this struct and make it into a response iterator. Oops. I don't know why I'm doing that. It's manually, it's just a habit here. I know it will automatically format it. Okay, so that is the response iterator, and then we can return that. Except, okay, now this needs to be an iterator. Alright. So now we can actually make these sort of quote-unquote higher order iterators, where we take one iterator and we pass it through. We can sort of, because we're making this new struct, we're also saying that, okay, yeah, this should include another iterator. Whereas if this was more generic, it would be hard to know, okay, what would the size of this iterator be? And it's impossible for it to, like, let's say this would be like any iterator. Then you can't store it. If we go here, so if this was not a pointer, right, and we try to put it in data, since this is a generic iterator, the generic iterator has data which is always the same size. Now I haven't really explained how this works here, but basically I wanted to avoid using pointers. That's the whole point here. So in order to have a generic data type, in order to be able to store any type of iterator, I just decided, okay, should 24 U8 should be enough. That's 3 pointers, I believe, and that should be enough to store the types of iterators that I'm gonna work with. But the problem is that if you want to have an iterator that includes another iterator in its data, then that doesn't work. So because then you have like a circular dependency here on itself here, so data will be, you would have to include another whole data object in this data object, so that doesn't really, it doesn't work. But this works because now we're explicitly defining this structure to have this size, so this works. Okay. Yeah, so I mean, I was just thinking now, like, you could perhaps solve it. I mean, other programming languages solve it by using reference counters. But yeah, anyway, so let's see, let's see, get responses. So yeah, so now we get a, so now we say iterator here instead. So this branch returns just duplication, which we don't really need to do. We can actually use the slice iterator, I guess. And this is also an issue now, because this now it's like, what would this be? So okay, I mean, I guess it could be a union, a tagged union. Does it make sense? Or this could be a tagged union. So this is like, I guess we could call it source. And it would either be shown options or what is it? Just a list of these. Well, what I wanted to do was use a slice iterator just over it, but then that would work in the case of generic iterators. But now I have to define this two different ways of doing this here. I mean, I guess it's fine, but now I have to have like a if in here. I guess it's fine. It doesn't really matter that much. I mean, it doesn't matter at all, basically. So we can basically switch on source, and we can say if it's shown options, then we do this. Oops. Otherwise, we have responses. We can just say, but now we have to do like a slice thing. So actually, we need more than just this. We need this and index. I guess this could be called like a slice. If slice is more than equal to, yes, slice response length, then we return no. Otherwise, we would return responses. Well, that would be the response. What's happening here? Oh. Alright. A little bit more involved here. So now, well, let's see. So we want to use this responses. Source equals to this. There we go. And we don't need to catch anything. And now moving to the source. Wait, return. Yeah, fine. Yeah, and now we don't need allocator. Nice. All right. We're only using it here. But yeah, so basically, yeah, we turn this sort of allocate the list and populate the list, look through pattern into more like making iterators. And so, I mean, it's a little bit more involved. You have to define a struct, you have to define these next reset functions, you have to think in a bit different way, but we do avoid these allocations. So you do get something out of it, at least. Which was the whole point of this here. Yeah, so now this is a response iterator. Now you don't need allocator. And we don't need to free the responses. And we don't actually need allocator at all here. Okay, very nice. Alright. I mean, yeah. I guess maybe what you could argue is, well, now we have a bunch of functions, I guess. I'm not sure if there's gonna be more like calls here and there, like jumps and stuff, and if that's gonna be worse. But allocate, I mean, technically it could cause a syscall to happen, so that's pretty bad. I'm not sure. I don't know. But you would have to, like, I guess test it or something. I don't know if it's even feasible to be able to test something like that. But anyway, so it just feels nice that we get rid of all the allocate stuff if we don't need to have it. Right, so now we don't have okay, now this is a downside to do this, because now we don't have length here. We have to, like, basically we have to iterate through the responses to get the length. Now that is actually a major downside here, and it's good that we see this, because now we can see sort of the pros and cons as well here. So how do we do this? Do we wanna iterate through them to get the length, or can we solve this another way? I mean, I guess we're only checking if it's more than 0, so we really just need to check if we have at least one response. So actually what we could do, has responses, is basically what we could do is just say if next is not equal to null, and then we have to call reset, right? Oh, I forgot, this is the wrong type. There we go. So if has responses is well, if responses next is not equal to null, because if it is null, then we don't have any responses. If it's not null, then we have at least one response. So now we can use that instead. So that wasn't too bad, but it is a trade-off that you will have to do when you use this. Oh yeah, this is, wait, no, responses, right? No field name responses. Oh yeah, this is called slice, that's right. And then this one is called responses. There we go. Active dialog responses. Okay, so we actually don't need it to be mutable, I guess. We just need it to be something there. Okay. Expected time found const. Alright, so this just needs to be a variable. Or I mean a mutable. I guess that's the same thing. Technically, if you're talking math terms, well, maybe not. I don't know. Mutable. I mean, mutable. Is that a term in math? Maybe it is. But it's like, I guess maybe it's slightly different meaning to it. Expected type showing for iterator. Yeah, so we just need to make it mutable. No field, name index struct. So this would be slice.index and slice.index. There we go. Expected type. Yeah, so the same thing here. Wait, const. Oh yeah. So now this one is different. So yeah, we don't actually have draw responses iterator. We also just call it from one place. So let's just change this to be a response iterator. And well, we can see here we're actually using the slice iterator and map iterator here to get the label out. Actually, we could make this like return I mean, or yeah, I don't know. Now let's just do this. We will make a response label iterator and responses is going to be response iterator. Next is going to be, so this would return a string, and responses next, or else return null, return end of label, reset. Yeah, so really easy to write this type of this is sort of like a mapper here. Pretty easy to write actually, so it's not really that big of a deal, I guess. It's just hard to write, like, I mean, it's not, what did we say, like maybe more generic type stuff. Alright, so now we don't need all this. We can say, well, actually this accepts a generic iterator, so now it's like a little bit of an issue here. So we get a response iterator. We can say, okay, let's just make this into any type. Oops. Alright, and then this iterator is gonna be, yeah, response label iterator. There we go. Alright, and then we don't have to, I don't think we have to change anything in here. The compiler is gonna like, it's gonna work here. It does a generic iterator here, but I think that's because the LSP sees that this is getting called with a generic iterator, so it actually fills this in here, which I was actually surprised when I saw this at first. All right, so now we don't have more compiler errors, so should we just try it, I guess. Oh, we get a crash. Interesting. Overflow. Recursive panic. Okay. Interesting. Oh, recursive panic. Okay.